Hello everyone, my name is Pino, and in this video we'll differentiate the following functions using the rules of differentiation. For our first question, we have to differentiate y is equal to sine 2x multiplied by e raised to the power x. We have a product of two functions, the sine 2x and the e raised to the power x. In order for us to differentiate this function, we have to use the product rule, which states that if you have y is equal to f of x multiplied by g of x, then the derivative of the y will be equals to the derivative of the f of x multiplied by the original function g of x plus the derivative of the g of x multiplied by the original function f of x. In our case, we can let the sine 2x to be equal to the f of x and the e raised to the power x as our g of x. Then the derivative of our y will be equals to the derivative of the sine 2x, which is equal to cos of 2x. And according to the chain rule, we also have to differentiate the 2x. So the derivative of the 2x will be equals to 2. And we multiply this by the e raised to the power x plus the derivative of the e raised to the power x. The derivative of the e to the power x will be equals to e to the power x, and we multiply this with the original function, the sine 2x. Simplifying, the derivative of y will be equals to the 2 multiplied by the e raised to the power x multiplied by the cos 2x plus the e raised to the power x multiplied by sine 2x. And this will be our answer for the first question. For our second question, we have to differentiate y is equal to cot x divided by ln x. And in this case, we have a quotient of two functions, the cot x and the ln x. So the quotient rule should be applied in this case, and it states that if you have y is equal to f of x divided by g of x, then the derivative of the y will be equals to the derivative of the f of x multiplied by the function which is in the denominator, the g of x, minus the derivative of the denominator, the g of x, and this will be multiplied by the function which is in the numerator, the f of x, and all of these will be divided by the function which is in the denominator, the g of x, but it has to be raised to the power 2. So in differentiating, y is equal to cot x divided by ln x, we have to differentiate the cot x, and the derivative of the cot x will be equal to negative cosec squared x, and we multiply this by the function which is in the denominator, the ln of x, minus the derivative of the function which is in the denominator, the ln x, and the derivative of the ln x is equal to 1 divided by x, and this will be multiplied by the function which is in the numerator, the cot x, all of which will be divided by the function which is in the denominator, the ln of x, but it has to be raised to the power 2. And this will be our derivative of y according to the quotient rule. For our third question, in order for us to differentiate this, we have to use the power rule, which states that if you have y is equal to x raised to the power n, the derivative of the y will be equals to the exponent of x, which is the n, multiplied by x raised to the power n, and we minus 1 from the exponent of the x, so we have n minus 1 as the exponent of x. Before we can differentiate the y, we express the square root of x. We express it as x raised to the power half, and we have that plus x raised to the power negative 3. So the derivative of the y will be equals to the derivative of the x squared, which will take the exponent of the x, which is the 2. We multiply it with the x raised to the power 2, and we minus 1 from the exponent of the x, minus the derivative of x raised to the power 9. The exponent of the x is the 9, which we multiply with the x raised to the power 9, but we minus 1 from the exponent of the x, so we have 9 minus 1, plus the derivative of x raised to the power half. The exponent of x in this case is the half, so we multiply the half with the x raised to the power half, and after that we minus 1 from the exponent of the x, plus the derivative of x raised to the power negative 3. So the exponent of the x will be equal to negative 3. We multiply it with x raised to the power negative 3, and we minus 1 from the exponent of the x. The derivative of the y will be equal to 2 multiplied by x raised to the power 2 minus 1, which is x, minus 9 multiplied by x raised to the power 9 minus 1. 9 minus 1 is equal to 8, plus the half multiplied by the x raised to the power half minus 1, which is equal to negative half. The positive multiplied by that negative will be equal to negative, and we have the 3 multiplied by x raised to the power negative 3 minus 1, which is equal to negative 4. And this will be our derivative of y according to the power rule. For our final question, we have to use the chain rule, since we have a function called the e, and inside the e we have the chord, and inside the chord we have the 4x. So the first step is for us to let u to be equals to the chord 4x, and our function y in the form of u. So we'll have y is equals to e raised to the power u in the place of the chord 4x. So we have to determine the derivative of the y with respect to x, which will be equals to the derivative of the y with respect to u multiplied by the derivative of the u with respect to x, and the du can cancel out each other, so that on the right hand side we have the dy divided by the dx, just like we have on the left hand side. We start by determining the derivative of the y with respect to u, and the derivative of the y with respect to u will be equals to the derivative of e raised to the power u, which is just e to the power u. And on the other side, we have to differentiate the u with respect to x, and the derivative of the u with respect to x will be equal to the derivative of the chord 4x, which will be equal to negative cosec squared 4x. We multiply this by the derivative of the 4x, which is just 4. The derivative of the y with respect to x will be equal to the derivative of the y with respect to u. We determined as e raised to the power u. We multiply this with the derivative of the u with respect to x, which we determined as negative, so we push that negative there. Negative cosec squared of 4x multiplied by the 4, and we have to simplify. So the derivative of the y with respect to x, this will be equals to the negative, and we have that 4 multiplied by e raised to the power u, and in the place of the u we substitute back the cot 4x, and this will be multiplied by the cosec squared of 4x, and this will be the derivative of the y according to the chain rule.